All right, guys, we are going to look at section 4.1 here in your book. And this is a little different video. I've not really done one like this before where I'm actually kind of just going through the examples in the book for you and reading some of it with you and so on. But they're good examples. And so there's no reason for me to reinvent the wheel here. We're going to look at the examples in your book. And so it's up to you if you just want to follow along here. If you have a physical copy of the book, you might want to have that open. But literally, I'm just going to go through the book here, and so you can just watch the screen as I go. So again, we're in section 4.1. It's talking about mental math, estimation, and calculators. We're going to talk about the first two of those, mental math and estimation. And so I just wanted to point out here that the book, the ebook, the electronic version of the book has some great resources here, videos and just different tools to show you how to teach these concepts, some how to learn the concepts. There's just great kind of little tidbits in here. So make sure that you look through that and maybe watch some of those things or look through them. Children's literature. I'm gonna do my best to post some lists of children's books that have to do with math. Talk about a great mix of subjects to have them reading stories, but also those stories have to do with math. And so I will do my best to get that posted into Moodle. So we're going to scroll down here. I'm going to put my glasses on so I can see what I'm doing. We're going to scroll down here to example 4.1. These are the types of problems that we want to be able to do ourselves mentally, but we also want to be able to teach our students how to do mentally. And so we're just going to look through these examples. We want to be able to do something like 15 plus 27 plus 25 mentally. 21 times 17 minus 13 times 21, and so on. We're going to do each of these problems individually here. And so actually I'm going to try to zoom in here if it'll let me. And probably because I'm recording, it will not. Nope. So we're going to look at this problem A right here, the solution. So in order to do this problem mentally, we want to rearrange this. And so we're using the commutative property of addition here, and because the 15 and the 25 are essentially numbers that are already have fives at the end of them, it makes them much easier to add. And so we're going to change this to where we add the 15 and the 25 first. And so it's kind of using the associative property here instead, but it doesn't matter which ones you add first because it's all addition. And so it's really just the commutative property. So the 15 and the 25, we're going to add that together first and get that 40 right there. And then the 27 is still there, and so we're just going to add 27 to 40 and get 67. So a much quicker and easier way to add that together. Okay, so you could do that again mentally in your head doing that. The next one is 21 times 17 minus 13 times 21. Now, I know some of these problems are a little bit contrived with the numbers that they have here, but not completely. A lot of this applies to really any kind of problem like this. And so what you need to catch is the fact that both of these numbers are being multiplied by 21. So you can essentially use the reverse distributive property to where you pull that 21 out in front. And so notice that, again, they just rearranged it here. 21 times 17 minus 21 times 13. So that 21 we can pull out in front. And so because the two numbers are being subtracted, the two numbers that are being multiplied by the 21, we can go ahead and write those as a subtraction problem. So 17 minus 13 is 4. And so that 21 times 4 now, we can do that in our head. 2 times 4 is 8. 1 times 4 is 4. So 8, 4, 84. All right. So make sure you're following that process there. Another problem here, 8 times 7. And some of you are already going mentally, that's 56. Well, 56 times 25 is kind of hard to do mentally, so we're not going to go that way. So instead, we're going to rearrange this order, and they're using the associative property, kind of the commutative property twice here. But it's all multiplication, and so it doesn't matter what order you multiply it in. So we're going to do the 8 times 25 first. Well, 8 times 25, well, 4 25s is 100, so 8 of them is 200. Now all we have to do is go 7 times 200. Well, 7 times 2 is 14 with the 2 zeros, 1400. Much quicker and easier in that order. Just rearranging the order is all we're doing. Okay. Different kind of concept here. 98 plus 59. Okay. We're kind of redoing the numbers here. And so this is a little bit trickier maybe than just straight out using the properties, commutative, associative, distributive, and so on. But we're going to change that 59. Basically, the 98 is just 2 off of 100, right? And if it was 100, it would be a lot easier. So we need to change that to 100 by adding 2 to it. Well, if we add 2 to this number, we got to subtract 2 from this number in order to keep everything balanced. And so that's exactly what they're doing here. They're changing the 59 to 2 plus 57, and then they're adding that 2 to the 98 instead. So again, associative property or really commutative property, they're just switching the order. Okay, so that 98 plus 2 is 100. 100 plus 57, 157. Okay. The next one, we are really just expanding these numbers and almost doing them to where you would line them up, vertically and do the tens place and the ones place here. But anyway, they're just kind of breaking these numbers down. And so the 87 plus 29, they're changing the 87 to 80 plus the 7 over here. They're changing the 29 to 20 plus 9. And so now they're going 80 plus 20 is 100 right there. 7 plus 9 is 16. And so now we just have 100 plus 16. That's 116. Much easier that way. Okay. Can even work with division. We're kind of, again, doing the reverse distributive property here. But as they point out down here, we're really doing the right distributive property, and that throws some people sometimes that you can distribute from the right. So we're going to take this number 168 and we're going to split it into numbers that are easily divisible by 3. And so we're doing some mental math just in that process, but 150 is easily divisible by 3, and that leaves 18, which just happens to be divisible by 3 also. And so that's the way we're going to split this number up. So 150 divided by 3 plus 18, and it is plus because 150 plus 18 is the 168. So 150 divided by 3, 18 divided by 3, we'll do those two divisions and then add the two numbers together. So 150 divided by 3 is 50, 18 divided by 3 is 6, and so when we add those together, the answer is 56. 168 divided by 3 is 56. All right. Okay, we're going to go down here to the next concept, excuse me, next example actually, in example 4.2, and we're talking about a concept called compatible numbers. And really we were already using this concept in some of those examples that we were just doing. And so just reading here, it says compatible numbers are numbers whose sums, differences, products, or quotients are easy to calculate mentally. Examples of compatible numbers are 86 and 14 under addition, 25 and 8 under multiplication, and 630 under division. So we were using this when we did the 168 divided by 3. We changed it to 150 divided by 3 and 18 divided by 3 because those are compatible numbers. Those work well with each other. All right, so just kind of catch that concept. Okay, this really is just more examples of kind of the same thing. Again, the example A is kind of like the example that we had up above. We're going to take the 4 times 25 first and make 100, and then times 13. The 1710, a little bit more complicated. We're going to kind of do what we did with that 168. We're going to make that 1800, because that's easily divisible by 9, minus 90, because 90 is also divisible by 9. And so if you look at their example, they go 1800 minus 90, all divisible by 9, and then do that reverse distributive property again, on the right again, and make it 1800 divided by 9 is 200, 90 divided by 9 is 10, and so 200 minus 10 is 190. And so the answer to B is 190. I'm going to let you look at that last one on your own. Compensation, I'm going to let you kind of read through that, and it's, again, kind of an example that we've already done. Again, some great resources here, some children's videos about doing these concepts, okay, or kids doing them as examples. The left to right method. The left to right method is specifically kind of doing it, again, to where you're lining those up vertically like you normally would, and then doing the hundreds place in this example, hundreds place, tens place, and ones place. Now, you kind of have to look ahead in the problem and see the fact that this particular problem, 342 plus 136, the fact that the ones and really the tens are both not going to force you to carry something over. They don't really have examples of that. That they tend to take to doing it kind of, again, the normal lined up method. Okay. Multiplying powers of 10, I think we've kind of already talked about this in one of our earlier videos, that because we use a decimal number system, that when you multiply or divide by 10, all you're doing is moving the decimal point. Okay? Or in this case, they're talking about also just increasing or decreasing the power on the 10. And so really all you're doing is kind of adding zeros there then. Okay? So make sure you know that mental tip about multiplying by 10. Special factors we've kind of already looked at. I'm going to go down to, there's some more examples you can look at here. I'm going to go down to computational estimation, which I believe this is now on the next page at least. This is not done by page here, so. But I want to look at this example 4.4. So they're asking us to find a range, so an estimate of these two problems here. First one, 257 plus 576. We just want a range of where that answer falls. Okay. Well, they're pretty roughly rounding these things off. And so they're doing a low estimate here by rounding the 257 down to 200 and the 576 down to 500. Now that's going to be a really low estimate, but that's what they're doing. You could easily do that to 250 and 550. But anyway, 200 and 500, that adds up to 700. So this answer on the low end is going to be above 700. And then the high estimate is rounding that 257 up to 300 and the 576 up to 600. Now this is going to be a little bit closer estimate, but on the high side. So we do that, 300 plus 600 is 900. So in other words, the answer to this problem is somewhere between 700 and 900. Okay, that's what they're asking us to do and asking you to teach your students how to do. Again, some mental estimation here. Okay, another example of multiplication, basically the same thing, rounding it way down, 294 down all the way to 200 and 53 to 50. When you multiply those, 5 times 2 is 10, and then you have 3 zeros, and so the 3 zeros go there, 10,000. Then rounding them up. 294 to 300 and 53 to 60. And so when we do that, 6 times 3 is 18. Again, the 3 zeros. So this answer is somewhere between 10,000 and 18,000. Kind of a large range there, but still, just trying to get a range of answers there. Okay. I'm going to let you look through this adjustment process here. It's kind of a combination of some things that we've talked about. And I want to finish up with rounding. Rounding gives people some problems, and so you need to make sure that you understand rounding. It's a critical concept. And the typical process of rounding is looking at, like this figure right here, looking at this 473. And so mentally what we want to be able to do is see, is that closer to 470 or is it closer to 480? And so that's why they've put it on a number line here semi-accurately to distinguish where that is. And so, but the process of rounding is, if we're going to round this to the nearest tens place, first of all, you need to know where the tens place is. In this case, it's the 7 in the number. And we're going to look to the number to the right of that. And so that's going to determine whether we keep that as a 7 or we round it up to 8. And so the way we do that is we look at that number to the right, it's a 3. Because it is 0 to 4 in that range, we keep the 7 and we round this number down to 470. Okay. If that number would have been a 5 or up through 9, then we would round this number up to 480. Okay. So that's the basic concept of rounding. Okay. If we were rounding this to the nearest hundreds place instead, then we would look at the 4 because that's in the hundreds place. And then again, we would look to the digit to the right because it's 470. Now we round up and this number rounds up to 500. 473 rounds to the nearest hundreds place. It rounds up to 500. Okay. And so there's some different things about rounding here that you kind of need to look at. But that's the basic concept of rounding. And rounding helps us in our mental math. It helps us to figure out some numbers to choose to be compatible numbers. Okay. I think that's all I wanted to look at. The rounding and the kind of the process of mental math and estimation are kind of summarized right here in this list of 1 through 8 items, and so you might want to look through that. The next concept is using a calculator, and there's another video about that. So thanks, guys.